Jamie!
Matt, it's podcast 16.
It is podcast 16, and not only is it podcast 16, it happens to be on the 12th night of Christmas.
Ah, is that when you have to take your Christmas tree down?
Yeah, we've got to take all the decorations down, I'm afraid.
Well, it's a good job I didn't put one up.
The Interplanetary Podcast. The exploration of space for the benefit of all mankind. Your hosts here in London, Matthew Russell and Jamie Franklin.
The Interplanetary Podcast. Putting the ace back into space.
So we hope all our listeners had a really ace winter break.
Absolutely, and Happy New Year. What are we chatting about today, Matt?
Well, I'll tell you what. Already there's been some great news out there in the old space front.
There has.
And the one that I really want to talk about is the Discovery programme.
Yes. This is 8 asteroids in 8 years.
Exactly, which is really exciting. So NASA has a thing called the Discovery programme, which is part of 3 sort of tiers of programmes that they do. Discovery, New Frontiers and Flagship.
Nice.
So obviously things like your Flagship or your Mars rover and all your kind of big ticket items.
Yeah, of course.
But Discovery is kind of, they're all capped at 500 million, so, you know, that small change of $500 million.
Yeah, that small sum.
and that actually doesn't include launch costs or sort of all the operational costs. This is just the sort of cost of the initial mission.
Yeah, that's a fair whack.
So although it's the cheapest of the 3, it's still pretty expensive. And there's been some ace missions.
So what are the bare bones of it?
So the bare bones is that unlike the Flagship ones, they kind of got that there's a specific reason for them. So they have to find out why the solar system, how the solar system formed and evolved.
Yeah.
Is there life beyond Earth?
Yeah.
And what are the hazards to life on Earth? So, you know, it's
3 pretty big bullet points, if we're being honest.
So obviously that is enormous, and it was one of the very first NASA programs that required there to be an educational outreach program too, as well, which was pretty cool.
Yeah. So we know that there were 5 original missions, and out of that 5, 2 won.
Yeah, that's right. So this is the first time in a while that there's been one of these kind of voting events to find a mission. Find the next mission. So yeah, there was 5 that they were looking at. Do you know what those 5 were, Jamie?
I do. The first one being the Deep Atmosphere Venus investigation of noble gases, chemistry and imaging. I mean, it just rolls off the tongue instantly.
What a coincidence that the acronym for that is Da Vinci. It's almost like they've worked backwards.
Yeah, they definitely got to the end and they were like, we've got to add imaging. And they were like, really?
So that was a chemical study of Venus's atmosphere, I believe.
Matt, what was the second one?
The Venus Emissivity Radio Science INSAR Topography and Spectroscopy Mission.
See, now you know why I asked you to say that and not me.
And that's Veritas. Again, I can't help feeling that they work backwards on that.
Definitely did work backwards.
And that
next one was the Near-Earth Object Camera, or the NEOCAM, that would discover 10 times more near-Earth objects than all NEOs discovered to date. However, the 2 that won, first one up was Psyche, that would explore the origin of planetary cores by studying the metallic asteroid Psyche. And finally, the second winner being Lucy, that would perform the first reconnaissance of the Jupiter-Trojan asteroids.
That is so cool, isn't it? And these
so cool.
The Psyche one, I have to say, really, and well, they're both amazing. They're both amazing projects. I mean, it's funny, isn't it? We seem to have a lot of missions to asteroids and not many to Venus, but the 2 Venus ones have been poo-pooed on this occasion. I wonder if that means that NASA has a New Frontiers or Flagship mission that they're thinking of to do Venus.
So for people who don't know much about it, I mean, let's go into it a little bit. So it initially was called 16 Psyche, which was apparently the 16th minor planet to be discovered.
Yeah. In 1852 by Italian astronomer Annibale di Gasparis.
Good work, Annibale.
Yeah. And for those who don't know, Psyche is the Greek mythological figure who married Cupid.
Ah, yeah, it's very sweet.
It's quite.
Although the mission's less so.
Yeah. But how cool is Psyche? So Psyche is this enormous asteroid that's out in the asteroid belt that looks like it's the core of a planet that's had its kind of outer shell ripped off.
Wow.
Yeah. So it's basically an enormous piece of iron nickel. Now
it sounds like it might be pretty hot. Am I right?
Yeah. If you were to, but see, this is one of the things that's really cool about it. If you basically, people want to have a look at, say, the Earth's core and see how that's kind of formed and what it looks like, and study the Earth's core. But the Earth's core is, of course, 3,000 kilometres below us. And do you know what the deepest tunnel ever dug is?
Go on.
12 kilometres. That is an unbelievable feat of engineering. So,
and the main reason is what?
Well, because as you dig, things just collapse. It's extremely difficult to have 12 kilometres of rock above you. And if you got down to the Earth's core, the pressure would be 3 million times that of atmospheric pressure.
Yeah, that's insane.
And of course, it's 5,000 degrees centigrade there. So basically, to go and study the Earth's core is an absolute no-go. So Psyche is brilliant. It's a brilliant opportunity to go and have a look at what the core of a planet might be like. Now, it's not guaranteed that it was a core of a planet, but it seems overwhelmingly likely, I think.
So even though we're talking about something that is the innards, looks like it's the innards of a planet, it's still massive. Oh, yeah. It's still absolutely massive, right?
It's huge. So it's 214 kilometres across and 181 kilometres across. So it's kind of oval, eggy kind of shape. So it's not massive enough. Well, it's probably massive enough to turn itself round over gravity, but it's so dense that it hasn't done so. And so it's unbelievably dense. So it's probably made of nickel iron, which is what you make bass strings out of course.
Oh,
so,
yes.
So if you wanted to sort of set up a factory making bass strings, it's probably or guitar strings.
I'll tell you what. Yeah, I mean, to all you string companies out there,
Didario.
I think you definitely need to get involved in mining this.
Well, well, not only that. So the iron nickel I worked out. Because there's 23 quintillion kilograms. Remember that's 23 billion kilograms of the stuff.
Yeah.
I reckon that's worth $2,530 billion dollars. which is actually,
I'm laughing because how can you even fathom that much money?
Well, it's 2.5 septillion.
And so we talked about this before. When a couple of podcasts ago, when we were talking about mining asteroids, we were interviewing. Who was it who was saying, yes, it might cost $500 million to get there and mine it, but if you get $1 billion back, then it's worth it.
Yeah,
right.
John Amabar was the person. I mean,
that's right.
This is the motherlode of metal. For sure. I mean, once you got on this, you'd never run out of metal again. I mean, there's way more accessible metal on this than there is on the Earth. So it would.
We just need to harness its. We just need to harness its power.
Exactly. Just need to go out and get it. Of course, John Amabar's point was the fact that you couldn't. That mining companies wouldn't want to do it until you incentivised it for them. So sort of. Whoever got there first could basically say, right, Psyche belongs to me. Boom. We're mining it.
Yeah.
Or even a little bit of it. Or just, divide it up to some mining companies. Which I think makes sense. Psyche, the actual, the mission for the, is this is going with a few different instruments. You've got the multispectral imager, which is a high resolution imager. So that'll go round... And that's 2 identical cameras that will be getting geological, compositional, topographical data. Yeah. And the second camera's there for redundancy and for mission-critical optical navigation. So it navigates using these 2 brilliant cameras. There's also got a gamma ray and neutron spectrometer, which...
standard.
Yeah, pretty standard, so that will map its elemental composition. And magnometer to measure its magnetic field, of course, and there'll be loads of radio science going on that will sort of determine its structure and topography in a sort of very high precision in using the information from the imager as well. So it's
I mean, if you haven't got one of these 4 things when in your briefcase when you're heading to work, you really need to take a good hard look at yourself.
Absolutely. And do you know what? One of the things that I was really loved about this Psyche mission is the principal investigator, Lindy Elkins Tanton, who on the notes for this particular podcast, I'll put a video of her talking about the mission before it was chosen. But she is very, very inspirational person indeed. There's quite a few articles on the internet about her. It's really good when you read about these people, and she's a classic example of just someone that's just so involved with science and has always been involved with science, and her career has taken her all over the place. So she's the director of School and Earth and Space Exploration at the Arizona State University. Now, it's worth mentioning the Arizona State University is involved in both missions chosen.
Okay.
So, she's the director there. She's got BSc in geology, MS in geochemistry, PhD in geology, and she did a PhD while being a single mum, by the way, all from MIT. So it's she's been a professor at MIT, impressive. Research scientist at Brown, a lecturer at St Mary's in Maryland. So, and she's twice named National Academy Science Kavli Frontiers of Science Fellow. And she's also been awarded Astor Fellow at the University of Oxford. So she's absolutely genius.
Wow,
and not
Lindy.
only that, I mean, this is the one I'm really jealous of, that she's got an asteroid named after her, the 8252 Elkins Tanton. Just how cool is that?
That is so cool. I mean, it sounds like she's spinning some serious science plates.
Oh, yeah, no, totally. And the story that she recounts on the video is that she went to a room called Left Field, which is quite cool. We know the drummer from Left Field, don't we?
That's right, yeah.
So, called Left Field, and that's at JPL. And this room's full of post-it notes and bits of Lego and stuff like that, and it's where people go to discuss the next mission and sort of design them.
I love that.
And the last one that had been in there was Maven, I think, and all the sort of post-it notes were all lying around the table, which I think amused her somewhat.
I love that it's post-it. It comes down to post-it notes and Lego. That makes me feel so much better.
Definitely mention Jim Bell, because he's the professor at School of Earth and Science again at ASU, and he's on both missions. But
nice.
So that's cool. So Lucy.
Let's speak about Lucy.
Yeah, give us the lowdown.
So Lucy is a robotic spacecraft which will visit target-rich environment of Jupiter's mysterious Trojan asteroids. Scheduled to launch in October 2021, the spacecraft is slated to arrive at its first destination, the main asteroid belt, in 2025. Then, from 2027 to 33, Lucy will explore 6 Jupiter Trojan asteroids. Wow, this is super cool.
It is super cool. Just so you know what a Trojan asteroid is, we've talked about Lagrange points before on the podcast, but just a quick lowdown of a Lagrange point. Say if you've got the Earth and the Moon, somewhere in between the Earth and the Moon, there is a point where the gravity pulling you towards Earth is the same as the gravity pulling you towards the Moon, and that's known as a Lagrange point. And there's various Lagrange points around the Earth. That's the most obvious one, and there's ones obviously relating to the Sun, etc., etc. Now, Jupiter has 2 Lagrange points, L4 and L5, where all these asteroids that are going round seem to sit. So one lies 60% ahead, 60 degrees ahead of the planet, and the other 60 degrees behind. And they orbit along with Jupiter on its 12-year circuit around the Sun. And the Trojans are a relic of the early solar system, so they're very, very interesting things to go and have a look at. And what I find really, really interesting is that they come in families just like the asteroids. You'd expect them all to be the same sort of material. So there might be lots and lots and lots of different reasons why these things form.
That's really interesting. And I guess we should talk about Max Wolf, who was the German astronomer that discovered them.
Yeah, that was 1906. He discovered the very first one, 588 Achilles.
Wow.
So since then, there's been 6,178 catalogued, I believe, but it looks like that in terms of the total number of Jupiter Trojans larger than a kilometre in diameter, there's about 1 million.
Whoa.
So, and over 1 kilometre in diameter, which is about the same as asteroids over 1 kilometre in the asteroid belt. So this is an amazing, chunk of the solar system.
I was about to say that's a lot of bass strings, but do we know what Trojans are made of primarily?
Like I said, they're from all different types of families. So some of them are metallic, some of them are chondrite, I think that's the word. So they're stony asteroids. Some of them might even be sort of comet-like asteroids, snowy, watery bodies. We won't know. I mean, this is one of the great things about Lucy going out there to have a look.
Let's go and find out.
Yeah.
By the way, when I say let's go and find out, I don't think that me and you personally should go and find out. As much as we would be, motivated, I think we should leave it to the experts.
Oh, don't be silly. Come on, Jamie, we can do it. Just so you know, Earth can obviously have the same Lagrange points as Jupiter. So there's actually, they've managed to find a Earth Trojan.
Okay.
Yeah, not to be confused with what people refer to as Earth's second moon, which is the 2016 HO3. So Earth does have its own Trojan that wanders round with it. But there's probably more, but there's only been one discovered at the moment.
Okay.
The guy in charge of this one is a guy called Harold F. Hal Leveson.
Okay.
And he's quite famous anyway, because he was the one that really was arguing for the distinction between dwarf planets and the other 8 planets. So he's one of the ones that demoted Pluto down. Although he was using different terms. I like his terms, Unterplanet and Uberplanet.
I mean, that is they're cool words and all, but I can't help but feel some negativity towards Hal. I'm on Pluto's side.
Yeah, particularly after we've seen how amazing Pluto is with all that data coming in from New Horizons.
Exactly.
It's unbelievable, isn't it? So his other achievement is writing a piece of software called Swift.
Yeah.
Which solves planetary equations of motions for billions of years.
Wow. So he's a pretty smart cookie.
Yeah, so in his words, because the Trojans are remnants of the primordial material that form the outer planets, they hold vital clues to deciphering the history of the solar system. Lucy, like the human fossil which it is named after, will revolutionise the understanding of our origins. So that's where it gets its name from, Lucy, because it's part of our...
yeah, that's a good quote. I tell you what, you should also, listeners, go to our blog, because there's a picture of Hal, and he's got a pretty epic beard.
His epic beard.
It's really good.
Beard.
Yeah.
He could live in Shoreditch with that beard.
He definitely could. He definitely could.
So yeah, that's going to launch in 2021. So yeah,
nice.
It's exciting, isn't it? So lots of exciting stuff going on there. And I love the Trojans. I want to read more about the Trojans, and I want to discover more Earth Trojans. That's what
absolutely. I mean, I love the stats from these asteroids. I mean, the size and the figure of money that. Of how much the metals on them cost. I mean, it's just insane, isn't it?
It's crazy, isn't it? Well, it just makes you realise how expensive getting into space is. The fact that they've been left untouched.
Yeah, I mean, mining on Earth is expensive, really expensive, and I mean, imagine taking that but doing it in orbit. I mean, wow.
God. It'd be unbelievable, wouldn't it?
The mind boggles.
So shall we go on to some more astronaut news?
Yeah, let's do it.
Other stuff that's going on, man.
Let's do it, dude.
One of the other big news that NASA announced also this week was that they're going the next 2 crew members for the International Space Station.
Yes, absolutely.
So there's Andrew Feustel.
Nice.
Who'll go up in March 2018. He's a veteran. He's been up on the space shuttle. In fact, he was one of the people that fixed the Hubble telescope.
Oh wow, good work,
yes.
Andrew.
So he's a legend. So obviously, when you look up Andrew Feustel, you go, "Oh, this guy's ridiculous." He's got a bachelor's degree in Earth Sciences, master's degree in geophysics.
Who hasn't? Everyone's got that.
And he's got a doctorate in geological sciences, and he's been into space 3 or 4 times.
Yeah, it's pretty good.
Now, an extra special one is Jeanette Epps, who was born in Syracuse, New York. and she is a PhD in aerospace engineering, another annoying overachiever.
Yeah.
And she worked at the Ford Company, worked for the CIA. So she's and she qualified to become an astronaut in 2011, and she will be the first African American space station crew member in May 2018.
That's awesome. That's really great.
That's going to be pretty groundbreaking.
That's really great.
Good work. She actually, tell you what she also did. She was on the Aquarius underwater laboratory in the Nemo 18 missions that NASA do. Yeah, which are sort of underwater training missions for the astronauts.
Incredible. Well, good luck, guys.
I know, genius. So yeah, that's really cool news. And also, they selected another mission to study black holes, which is the IXPE, the X-ray Polarimeter Explorer.
Ah, yes.
Which is 3 space telescopes. Did
Three
you hear that electric? Yeah, 3 space telescopes. Hear that electric guitar?
I did hear that electric guitar. I thought I'd just let it slide. Excuse the pun.
I think it's people are getting excited and just breaking out guitars.
If you're talking about studying black holes, you need a guitar riff.
Absolutely. Maybe
you need
can pretend this is the backing music to our What's Else in the News section. And NASA also have awarded SpaceX and Boeing a few more crew rotation missions.
Oh, good.
Which is a bit peculiar, being that neither of them managed to do one yet.
Yeah, exactly.
So they've got 4 additional missions.
Yeah.
Shami Chattery of the Cornell University published a work which basically they found the source of a very fast radio burst. That's been put down as one of these kind of wow signals. It might be aliens. So they've managed to pinpoint where it's coming from. It's coming from a dwarf galaxy.
Yeah.
The
media does get very, very alien heavy as soon as there's some kind of radio burst, don't they?
Yeah. If it might be aliens, it's not aliens. That's my rule of thumb.
That's the rule. Yeah.
So SpaceX, they're going to try and launch in 3 days' time on January the 8th, which is the Iridium Next satellites. So it's going to be 10 satellites.
Yeah.
So they're all sort of stacked up in the fairing at the moment, waiting to go off from Vandenberg on January the 8th. So I don't know if that's been put back yet, but we'll see.
Well, let's check that.
Yeah, so I'll tell you who else has been very, very busy is the Chinese.
Oh, what have they been up to?
Well, they've released a kind of a press release saying what they're going to be doing over the next 5 years, and it's very, very impressive. And to most people, the Chinese don't ever say stuff that they're not going to do. So
yeah, that's true.
If you read through what they're going to do, it's going to be pretty impressive. They're going to, for a start off, they're going to try and do 30 space launches in 2017.
Wow!
So bearing in mind that Russia.
Well, what was the maximum we had this year?
I think 23.
23 was
23 with America, and 22 if you don't include the blown up Falcon 9.
That's right.
So China. So 30 is going to take them into a different league.
They've thrown the gauntlet down, Matt.
They certainly have, and they're also sending a lunar probe to go to the moon and sample return mission.
Nice.
So that's pretty big. It's going to send up its first ever cargo spacecraft to the Changzhou 1.
Nice.
Yep. And that's going to obviously rendezvous with the Heavenly Palace Tiangong 2 space lab. And they're going to test out automated refueling technologies.
That's very cool.
The plans of their future space station. So that's amazing, isn't it?
Yeah, that's very cool.
But not only China have been busy, India are extremely busy as well.
What's going on?
So India have announced that they're going to be launching 103 satellites on their next polar space launch vehicle.
Wow, okay.
No, that's pretty cool.
One or two. Okay.
And they were going to launch 83 at the end of January, but
amazing.
But someone said, "Oh no, it's all right. We'll give you another 20 to add on to that." if you wait a second. So they waited, and now they're going to take off in February. But that's 103 satellites in February in one go.
That's amazing.
Which is obviously a record.
Oh, I was going to say, I wonder what the most is before that.
Yeah, well, I mean, I think it is the Indian one earlier this year, wasn't it? Which was something like 26 or something like that.
Incredible.
But it's absolutely amazing. And there's a principal payload, the Cartosat 2D, but everything else is micro satellites. So yeah, that's really cool. And not only that, the Indians have been talking a lot about that they're thinking of going after they've been to Mars, of course, but it looks like they're going to be sending stuff out to Venus and then on to Jupiter. So they're really, really busy.
Amazing.
And they're also going to fly their GSLV Mark III for the first time.
Oh, glory.
Well. So that should be really exciting. So the Indians are also doing some pretty exciting stuff.
Well, people need to keep up with China and India. Come on.
Yeah.
Where you at? Where you at?
So, and there's on the 10th, we've got a Japanese launch of an SS-524 rocket, which is basically a sounding rocket, but it's carrying a little CubeSat up.
Yeah.
So that should be pretty cool.
Nice.
So that's it. I think that's been a pretty busy week for space again. I love the Psyche mission. What about you, Jamie? What's your favourite?
So good. I do love that. I think Lucy is fantastic as well. I'll tell you who else we've missed out, Matt. We should mention Carl Sagan.
Oh no, Carl Sagan. So Carl Sagan, I saw this quote and I thought that it was so poignant for today's times that do you want to read it out or should I?
Let's share it in two. I'll start the first bit.
Okay,
here we go.
Start the first bit.
We've arranged a global civilization in which most crucial elements profoundly depend on science and technology. We have also arranged things so that almost no one understands science and technology. This is a prescription for disaster.
Yeah, I worry that pseudoscience and superstition will seem year by year more tempting, the siren song of unreason more sonorous and attractive. Where have we heard it before? Whenever our ethnic or national prejudices are aroused in times of scarcity, during challenges to national self-esteem or nerve, or when fanaticism is bubbling up around us, then habits of thought familiar from ages past reach for the controls. The candle flame gutters, its little pool of light trembles, darkness gathers. The demons begin to stir.
I mean, it's incredible. It's like something from Star Wars, but actually real and completely relevant.
The solace that I got from it was that the feelings that we have at the moment are the feelings way back 20. That was written 25 years ago, or probably
absolutely.
more. And you think these things come around every now and then. So
that's true.
Listeners, thank you very much for listening. And if you've got any questions, please send them in. Actually, I will nod to a listener called Dick Wall.
Oh yeah.
Who was the person that sent me the radio astronomy burst article.
Oh, nice one. Let's have some more of those.
Thank you very much. So sending that more in, and please subscribe on iTunes and leave us a lovely review.
Hit subscribe.
Would really help.
It really helps.
So if you've listened to this, enjoyed it, pop us a review and a nice 5-star. That'd be genius. Or whatever star you think's appropriate. We'll read the reviews and we'll act accordingly.
If you do all that, which will take 2 minutes of your life, we promise that we'll get you a slice of pie that's almost been into space.
I tell you what, we should do some competitions. We'll do some competitions this year and send out some proper stuff.
Yeah, let's do that.
So watch out for that.
I mean, we've been skinflints in 2016. 2017 is the year of generosity.
Absolutely. We've got some really good interviews coming up this month, I should say.
Yeah.
So in the next 2 or 3 podcasts, we'll try and do a couple of interviews a month with super space experts. Keep your ears peeled out.
Keep them peeled, pigs.
That'd be yucky. Okay, thank you very much for joining us.
See you next week.
Bye.
Bye.